Start already. So my talk is today about GPS threats and countermeasures, and I named it Another Place, Another Time, because we can manipulate the signal from GPS and alter with the data, for example. How it is done and some technical background I will show you also in the presentation. It's more focused on yachts because my previous things that I did were talking about yacht security and hacking stuff in yachts. So, why it is not working? Now it's better. Yeah. So the outline for today is we have a short introduction about me, then GPS 101, so that we have a knowledge about how GPS is working, what kind of systems are there, and how many different GPS systems are now available. Then we take a short overview into yacht systems and GPS there, and then we focus on the threats and countermeasures in that. So, and at the end, then we have a little bit time for some questions if you have, or otherwise we can also discuss on the outside. Yeah, GPS. Everyone is using it, but mostly nobody knows how it is working. And yeah, so there are many names for that: GPS, Navstar, Galileo, GLONASS, Baidu, and IRNSS. So these are all different versions or GPS systems that you can have now. And yeah. So many names, but mostly all using the same thing. So the thing that you are using with that is, it gives you positioning information about where you are and what time it is. And yeah, so altogether, they are named as a Global Navigation Satellite System, or in short, GNSS. So that's the general term for the GPS systems. Yeah, who am I? As already named, Stephan Gerling, or on Twitter you can find me under Obi1666. I'm older than the internet, so it started with a Commodore 64. Yeah, some certifications I have, like in forensic analyst, a CISSP, Microsoft Certified System Engineer, CCNA, and whatever. I'm an electronic specialist, worked several years in the German Army, and was responsible for maintaining and repairing navigation systems for helicopters. And in my free time, I'm also a firefighter since more than 31 years now, so that's one of my biggest passions. And yeah, I'm working in the oil and gas industry for my company Rosen, and also for a spin-off of that called Certivation. By the way, I avoid warranties. I buy stuff, open it, and look how it is working. And I'm volunteering in the Geraffel group. It's a part of the CCC camp, or the CCC group, and yeah. And also in the I'm the Cavalry. There I'm in the maritime sector and doing their security stuff in maritime systems. I think we also make this year a DEFCON village about maritime security. So we will see if it is accepted or not. Yeah, as already heard, so many systems. So GNSS is the global term for Global Navigation Satellite Systems. And where the abbreviation came from, and the original one is, so the first one that we had in place was a Navstar GPS. So it was from the United States of America. They introduced the system in 1973, or they built up the development for that. And so Navstar is then for Navigational Satellite Timing and Ranging Global Positioning System. And the short-term GPS, it's commonly used by everyone when we're talking about yeah, positioning systems. So that was the first one. Then the Russians introduced their own systems. They called it GLONASS. And GLONASS is von Globalna Navigazione Sputnikova Sistema. So that's the Russian wording about how they name it, and the short version is then GLONASS when you put the names around. Then we have an European version. they introduced it a little bit later because they want to not respond on the military services from the GPS from the US. So formally, the GPS system was introduced by military services, that it is a military positioning system. And in most of the wars since 1990s, where GPS is used by also aircraft and maritime sector, the military always shut down the system in a conflict, for example. So, and they still do it. So therefore, Galileo was then also introduced. So it's a completely free system from the European Union, and it's free for everyone to use it. So you have only to follow the guidelines, and then you can use it for that. And yeah, China also has its own one. They called it Baidu. And the name from the Chinese version, it's from a Big Dipper asterism system in the air. So in the Chinese, this asteroid system is called Baidu. And the Chinese word you can also see there. And last but not least, we have also an Indian version about that. So all other systems are global, and the Indian one is only a local system. So it's only coverage over India, and at least 1,500 to 2,000 kilometers in range, so that it covers complete Indian, and that's it. So they have 7 satellites for that, to cover India atmosphere for the services. Yeah, it was introduced as Indian Regional Navigation Satellite System, and after it comes operational in 2016, it was then renamed by the Prime Minister in Navigation Indian Constellation, and it's in short it's a NAVIC. So that are the names for that. Okay, so we have so many things of that. Most of autonomous systems are relying on global positioning systems so that they know where they are. And as we learn later, you can find out that you can alter the position where you are. So that's not that big deal. So it's called GPS, and I think there was an error on the slide. Okay. Here a short overview about the history of the systems. So the first one started in development in 1973 with the GPS from NAVSTAR, and the first satellites were in the air 1978, and it was fully operational 1990. No, you can use it in 1990 already, but fully operational it was 1995. The Russian version started a little bit later, so 3 years later, and they had the first satellites 4 years later in the air, and were nearly at the same time fully operational like the Russians. The Chinese started in 1980, and it took more or less than 20 years to get their first satellites in the air. And but after then, they were already operational since 2012, and since next year they have their last satellite. So end of the year they will fire up the last satellite for them, and then it's global operational for the Chinese. The German version, or the European version, I must say, they started in 1999. Other sources saying they started in 2003, so it was depending on which sources you're taking. And the first satellites they shot in the air was on 2005. Mostly the Russians fired from their rocket areas in the air, and it was operational and in 2016, and should be fully operable also next year. So there are currently 24 satellites in the air, but they need up to have 30 satellites for that. So 24 satellites are used for the positioning system, and they have 6 spare satellites for that. And Latest one is the Indian version. So the development started in 2004. It's not that far away, and the first satellites were then in 2013 in the air, and that was the first one. And then in 2016 they had all 7 satellites up in the sky. So yeah, that is only a short overview about the history when the systems were there. What you need for that is, okay, each satellite is sending a signal. So here we have an overview about which kind of frequencies they are using and in which kind of bands they are working. So mostly the public versions are in the L1 band. So the GPS is working there, GLONASS is working there, Galileo, Compass, it's the former name of Baidu, and also the SBRS, it's a special operational system. But yeah, mostly they're using in the right sector the L1 band. So the L2 band, it's a more encrypted signal, and it's only available for military services. So they have another frequencies that they are using, and they're using some kind of encryptions for securing the and making the data more reliable, so that nobody can alter the information about what is transmitted. And the L5 band is then also used for some backup reasons, and also some test frequencies. Yeah. So to have a broader overview, I have write down all the frequencies used by which system. And there you can see already we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 or 12 frequencies that the GPS systems are using. So when you're now thinking about jamming or spoofing, then there is a broad range that you have to alter with the signals. Just as an overview. How does it look like in the air now? So this is, by the way, a satellite from Galileo. That's in the how it looks like in the orbit. The sending power of one of those satellites, depending on the systems using. So some of them are sending with 600 watt energy. Some of them are also up to 1,500 watts of sending energy. And in the right picture, you see how far all the systems are away from the Earth. So it's quite busy on the air there. And each system, yeah, GPS has 24 satellites, GLONASS has also around 24, Galileo has 30 satellites, 7 for the Indian, and so on. So there are so many satellites in the air for so many systems, and they are all in a range of a couple of kilometers. Yeah, that's for that. So what we need for positioning information. So to have an correct position information, you need at least, at minimum, you need 3 satellites inside of view. So there must be 3 satellites over you that you can maybe look up. You can't see it because it's too far away. But with those 3 satellites, you can already have an positioning information, because every satellite is sending a signal, and your receiver then receiving the signals. For example, your iPhone or your mobile phone. Okay, and from how they calculate the position from that is that you can say each satellite is sending the information from the satellite. Okay, this is satellite 1, for example. My sending time is also transmitted. So the first signal that they send is the time when the signal was sent from the satellite, and yeah, that's the first information. Then the second one is that the satellite type, and that's it. So from that, then you have on the receiver, then you have the receiving time. So In the first stage, the receiver has a different time, for example, because the time clock of a receiver is not that accurate like an atomic clock in a satellite. So that is then calculated with the information sent, and with the first information they get, they also changing the clock internally in the receiver. So then you're receiving also the other satellite informations, and from the 3 satellites in position, you know, okay, the satellites are in that position, and I must be anywhere in that direction, because with the 3 satellites you have a pointing information about where all the satellite information crosses, and that's the point where you are. For correct timing information, you need also a 4th satellite. So with 4 satellites inside, you can have already a correct timing information. And with those 4 informations then, the receiver calculate all the information then necessary. It's a little bit difficult, but just only for the overview about that. So security is also not really implemented in most of the system. For the military services, yes. So they're using some kind of encryption, and it's not public available. But for all other systems, there is no really security inside. I said here for Galileo, yes, but it's only for special services like search and rescue and so on. They can use the secured version of that signals. Yeah. As all they have, then it's spoofing and jamming is possible for that. A short overview about NASA. Already said, they introduced in 1973. Operational since 1993. Then they lost some. No, there's an error in. Sorry. Forget this slide. We switch this also. Okay. Yeah. Galileo. If you want to know if your mobile phone, for example, is using already Galileo, you can look up on the website usegalileo.eu, and then you can look up, for example, for the maritime equipment, for the road, for trains, for aircraft, for mobile devices, or IoT devices, and so on. There's a complete list of all receivers that are already capable for doing that. I know from iPhones, for example, that since the iPhone 6, they are having the capability to receive the Galileo information. GLONASS, it's a little bit difficult, but it's sending on the same frequency. But there's another signal information about that. Okay. So that was the short overview about a little bit how it is working. So this one is now a German picture about, because we're coming now to the maritime sector. There was some news about hacker changing yachts' GPS signals. So there was an university in Texas, in Austin. They did in 2012 an experiment on a 65-meter yacht and had their equipment on board. And they changed the position by 3 degrees of the ship on the course. So the ship then changed the course for 3 degrees. And but the navigation system say, okay, the system is on the same track, but the GPS is completely altered. So on the chart display, you had the information you are on the right track, but in real life, you were a couple of 100 meters away from that track where they were. The thing how they did it was they had their equipment on board and they are overriding the GPS signal coming from the air because they had some tools to use that. And they slightly powering up their signal so that they override the original signal from the satellites because the receiving strength of the signal of the satellites is very low. So when you then have a transmitter in near sight that has more power, then the signal is then used. So, yeah, so they proved that it is possible, but the thing that was not mentioned was in that talk was they needed the equipment on board, and they had to slightly, step by step, change the position. When you just give a new position to the maritime ships, then some receivers will detect it, that there is a jump in the course, and then they will ignore it, or they will show up with an information about that. Even a GPS receiver have when you have the 4 satellites inside, they have a lock indicator that you have a correct signal and that the receiver is locked. Yeah. There was other news about that, and okay. How it look like in yachts. So here we have a big overview about the complete maritime GPS and navigation stuff. And I'm not sure is it really viewable. So when we look here, the yellow part, the yellow lines, it's for the autopilot system. And under the yellow part, there is a small white device. That's a GPS antenna. So, and in the maritime sector, the GPS systems are sending the signals onto the NMEA bus. So it's a serial bus in the past, and nowadays on newer ships, you have also a CAN bus like that. And yeah, the receiver is receiving the positioning information from the sky, and is sending then the positioning information on the CAN bus, and all other systems are using those informations. So the university showed that you can alter with a GPS signal, but there are other ways for do that. As already mentioned here, so the GPS sensor is receiving the information and send it on the NMEA bus. And then all other services that using the positioning information are then, for example, the AIS, so the Automatic Identification System, and vessel traffic services, and the electronic chart display, also using those informations. So when you're now able to change those information, then you have a complete different view of that. So why is this important? Is because of more and more from these autonomous ships are coming now. So 2017, Rolls-Royce had done an experiment with a fully automatic ship. So they laying at the harbor, they going on their way and coming back later then. And so everything is then also controlled over the air. There was an air controller that is using that, but also the positioning information were all the time from the GPS systems. So that's that. So 2017, it was the showcase from Rolls-Royce, and it was a 28-meter long tug called the Switzer Hammond. Yeah. They did it in Copenhagen Harbor, and the captain for the ship was not on the ship itself. The operator was somewhere else. Yeah, and they did it completely automatic. And for that, also the GPS system is used. We're coming now to the funnier part of that. So what kind of attacks we have and what kind of countermeasures we can have. So okay, there are only two things that you can make. So you can jam the signal or you can spoof the signal. That are the only two attacks for the GPS itself. In the maritime section, then you have also the CAN bus where you can alter the information. So, two scenarios, jamming and spoofing. Jamming is quite simple, just fire up some kind of a transmitting device, like an hack RF or whatever. So I have some here. So with an hack RF and the right antenna, you can do already your stuff. Or when you use a blade RF with a GPS antenna, you can also do the jamming things. And these devices can also be used for the spoofing. So spoofing is a little bit more complicated, but it's also possible. For less than €1,000, you have already equipment in place that you can use and where you can gamble with the signals. Jamming is quite common. So in the past, in the Eastern Pacific, there were reported more and more GPS anomalies, mostly varying maneuvers from the Russian side, or when the NATO troops made their own military maneuvers. So during that times, they mostly jam the GPS signal in that area, or slightly reducing the accuracy of the signal, so that there is a different positioning range in that area. So normally you are, let's say, around 3 meters in accuracy, and they can change it up to 100 meter or 200 meter or even more. So that's what's then done with the GPS system in that area. And there's also a report about that. I have it here also as a link, where they figured out in Norway in planes that their GPS signal was altered, and then they started up with an helicopter with an directional antenna, and then they could then figure out, okay, the direction of the jamming signal was more or less from the Far East area, so it might be Russia or somewhere else in that area. So it's not really clear where it was coming from, but it was more or less from the Russian area. And for all that stuff, in past, the US Navy were relying on only GPS navigation, and they stopped with teaching traditional navigation with a sixth sense, for example. After they heard more and more about attacking for the GPS system, they starting again teaching their captains in sixth sense navigation, in classical navigation for that. So the first trainings were, by example, then in Germany. So the US Marine then trained by Germans in navigation again for that old stuff. So sometimes it's very good when you know how things work in traditional ways. Okay, for the GPS jamming, the chart we have already seen. So we need a couple of frequencies where we have to jam the signal. So if we only want to shut down one GPS receiver, then it's very easy. But to be sure that you shut down everyone, because most airplanes or ships or other devices have more than one GPS receiver. In the commercial navigation from ships, you need at least 2 different GPS systems. And then you can get rid of your traditional C charts, then you have only the electronic ones. So for that, you need already to know which kind of GPS system they are using to shut down both systems, that they have the faked information. For example, the GPS, most of the systems are working on those frequencies here. And for that, you can buy online GPS jammer for that. It's quite easy. They're not so cheap, so there's a website for that. Just go there, and you can buy GPS jammers, you can cell phone jammer, and so on. So the range is from, I think, $70 up to 600, 700,000, and so on. So I picked up a few of them. So there's a small USB GPS jammer, $79, very cheap. You can also have a mini GPS jammer or anti-tracking device when you take a rental car, or when you maybe think someone has, in police cases, sometimes they putting a GPS tracker on your car that the police can know, okay, the victim is now driving there and there. For that, using those devices, the GPS tracker is not working anymore. And there's also another one you can just put into your cigarette lighter jacket, and then it fires up with everything, and jamming the GPS signals for that. The strength of the signal is not that much, but it's enough to to jam the signal for your car, for example. Yeah. Then we come to the spoofing things. So for that we need a little bit more. So you can buy commercial tools for that. So they called GNSS simulator, and you can also buy them. Here I have one example from LabSat. You can buy a range of GNS simulators for that you can test your development of your GNS receivers, for example, and so on. So this is one thing that you can buy. But it costs a lot of money. I'm not sure how much it is, but they're quite expensive. So, and there must be a cheaper way for that. And the cheaper way is we just do it ourselves. So what we need to spoof a GPS signal? First of all, we need the right tools. So you can start with an hack RF and the right antenna. Or the other one that I use is a blade RF. Blade RF also with the right GPS antenna. And with that you can already try your own things. But a good advice for that, don't mess with the signals and don't disturb other ones with that. So it is always a good decision to have a Faraday cage for that, or I use mostly some kind of these Faraday, you can buy them as a forensic bag, so it's completely shielded, put your stuff in there, and then you can test it and no signal is going outside of this bag. It's also good for mobile phones. You put the mobile phone in and nothing is going out. So just only as an advice. So for the DIY spoofing, we need also some software. So there are a couple of tools available for that. And the easiest one is just download from GitHub the GPS SDR simulator software. Just download it, follow the instructions, and it's operatable with most of the software-defined radio stuff. The URL is also there, or you can just Google it. Yeah. Then the complex part is then how to fake the signal. So every satellite position is changing every day. So because of that, there is also a daily update file about the correct position of each satellite in the orbit. You can download those files, for example, on the NASA website, where you have the daily GPS position of each satellite. And with that information, you can then generate your own pseudo-range simulated file for that. So this basic file with a position is needed. And the second thing that you need is your own position that you want to submit to the victim. So just take some latitude, longitude information about which kind of position you want to fake. Put it in a CSV file, and you have then the position for that. You can also make some tracks for that. For example, if you want to play with Pokemon Go and don't want to go every time, just make a receiver that is always done it in the same speed. But think about the right speed, that you are not too fast, because Pokemon Go is also detecting when they spoof GPS signals. Okay, we need to download the file from the NASA website. We have our own separated file with our positioning that we need, and from that we can then generate a file that's then called the simulation file. And this simulation file is done with the GPR SCR simulator software. So this generates then a binary file with all the information needed. So, and the last thing, what we then do is, this file we have then to transmit via an SDR device. You can use the hack RF or blade RF. You can use GNU radio for that, or you can just take, for example, in a command line, in blade RF command line interface, So here you have the commands that you need. So we have to set the frequency on the right frequency. So here in this case, we have the GPS frequency used. So 1575.42 megahertz. Then we need the right sample rate. And for GPS, we need 2.6 megahertz as a sample rate, with a bandwidth of 2.5 megahertz. Then important thing is the signal gain. So in this case, we're reducing the signal strength slightly, or no, not slightly, so already very hard. So because when you use the full power to send it, you're blasting too much energy on the GPS track. So just reduce it as much as possible, and then so minus 25 is a good beginning point. If it's then too low, you can slightly start putting it higher. And yeah, and we need the generated file that we had in the past. So in the first step, we generated a simulation file, and in this case now we're using these GPS sim binary file as an input, and it's also said, okay, it's in binary format. And the last thing is then just submit it, and then you're done. Yeah, I cannot show how it is working now, but yeah, in my lab environment I had it working. In the field, it's a little bit complicated because of showing then, or also showing here as a demo. It's a little bit quite illegal. Yeah. Okay. So back to the maritime part. We had known that, we have learned that on the NMEA bus, on the CAN bus, there are also the GPS information. So how we can alter with that? So when you have access, for example, to the CAN bus, then you can put there some small computer device like an Raspberry Pi or so, and install a software like the NMEA generator for that. So this is a software you can download at Altsoft. So it's called GPS Simulator. It's connected then via a COM device or serial port, and then you just can send out your faked GPS information onto the CAN bus of the ship. So that's very easy for that. When you think now, okay, who will have access to a yacht, to the CAN bus, for example? You can rent them. Just rent one of the bigger boats if you have enough money for that, and then you have access to all the devices on the ship. You have to find a slot for that when the captain is not looking, and then yeah, you can do your stuff what you want. I think for a 40-meter yacht you're paying 200,000 euro for 1 week or so. When you rent it, it's not that much. It's too much for me, but yeah. Yeah, that's one scenario that you can use. And when you want also to experiment with GPS receivers, this is a very cheap device. It's a system on a chip. You only need power, and then you have a serial port where you can get out already the GPS information. So when you want to test your GPS spoofing device, just use one of those small things. I think it costs 13 euro, something like that. You can buy them online on electronic stores, and then you have already the things that you needed for your test development. Yeah. So now we knew that it is possible to jam or spoof the signals, but what we can do for that? So it's very hard. Jamming, how we can prevent jamming, that's quite difficult, but there are already some research projects in that. So the German DLR has a research project called Galant. So on the right picture you see a flat antenna. The flat antenna is provided with a 2x2 antenna array. And by having those antenna array, they can calculate, because they know the correct position of the satellites. And with those information, they can calculate, okay, when the satellite is sending the right signal, all 4 antennas have the same information. When there is a spoofing device, for example, it must be more or less from the side. And the antenna array then detects, okay, maybe when they're sending from the left, then the 2 antennas on the left have more strength in the signal than the 2 antennas on the right. And then the other position is already is also from the air. So by comparing those informations, then they can see, okay, there is someone spoofing, and then they can filter out actively the spoofed signal and letting bypass only the original one. When you go to the website, the link is under the picture. Then you can read more about that system, how it is working. So they still testing it. The tests are very, very positive, and I think in a couple of years we will have it as an active system anywhere. But what else we can do? Last week I found something, let's buy a firewall. So is this kind of new snake oil? I don't know. So yeah, there are already GPS firewalls available. So I found only one now. The Blue Sky GPS firewall from Microsemi. That's the first one that I found now. Just buy it, and this is what they claim. So it protects the GPS system against spoofing and jamming threats. Software engine analyzes the GPS signals, and the GPS signal data is received and evaluated from each satellite to ensure compliance, along with analyzing received signal characteristics. So that's what they claim on their prospects. You just put a device between the antenna and your environment, and then everything is fine, hopefully. I'm not sure. I've not tested it. I will try to buy one for the company. We're using also GPS receivers in the company and build our stuff with that. So I will try to look up how it is working, and is it really working or not? I don't know. Yeah. So then we're already coming to the last things. GPS attacks occur quite often, so mostly jamming. First products are available for protection. One is commercial already, and one is in a research project. And also spoofing is not that easy, but it's still possible. Most of the spoofing test environments also for DIY are only for the GPS sector. For Galileo, it's a little bit complicated more. And and then I come to the last thing. May the force be with you. And thank you for attending my talk. Some questions, anyone? Oh, there. Yeah.
Good afternoon.
Hello.
As I saw, GPS satellite launched in 1973, and India launches 2013, right? So the accuracy, my question is related to accuracy actually. So the Navig has 1 meter accuracy, and a GPS has 20 to 30 meter of accuracy. So I mean,
this one you mean?
Yep. So my question is, I mean, GPS is developed in 1973, so it's almost 50 years.
Yeah.
So I mean, why their accuracy is not that much effective, and then India has that much effective? 1 meter is accuracy. So that's what my question is.
The development of the devices are starting already in 1973, right. But the first satellites a couple of years later. And you are asking now why India has its own satellite system. India was sponsoring also the Galileo project. So they, I think 300 millions they wanted to found into the Galileo project. But then a couple of years later, after they figured out that also the Chinese peoples are sponsoring Galileo, then they said, okay, when China is also doing their stuff with Galileo, so we put our effort out of that and doing our own stuff because they are frightened a little bit about the Chinese. So that was the story that I figured out for that. So and that was then the reason why they started the development in 2004 for their own satellite system in India. So it's not planned as a global one, but only for local India. And the other thing is, they don't want to rely on anyone else, so they build their own satellites, they build their own electronic, they build their own receiver and their own base station at the ground, so that they can control it for themselves, and nobody else responsible for that. So that was, I think, the idea why India did its own one. The accuracy. Depending on the on the signal what they're sending. So the positioning information and the accuracy is also in the signal. It's modulated on the signal. So GPS is a little bit not so accurate like the Indian one. Maybe that helps a little bit. Pardon me? I didn't understand the last things.
Hello. Is it audible now? Yeah.
No, yeah.
See, apart from the positioning information, I just learned that Chinese are having, they are giving other facilities also, like messaging and all. Is it true? Or can you throw some light on that? Means any other, apart from the positioning information, is there any other facility which is being provided by Baidu?
That I don't know, no. So, I don't know about that.
Yeah. Thank you.
Okay. Someone else?
Actually, I have another question.
Okay.
So, if I want to jam a signal of a satellite for a full country, is that possible?
Pardon me, the last
I just want to jam the signal of a satellite for a full country, particular country. I just want to jam all the signal. Is that possible?
I think it's possible, but you need very strong transmitting devices to disturb all those things. It could be, yeah, but for a complete country, yeah, it's expensive. But maybe it's possible. Okay, thank you. And one last question.
Yeah, hello. We've been using the, it's not just for the positioning, it's also for the time, the global synchronization of time, right? So are there any notable spoofing events that have happened and disturbed the time sync across the globe?
I've not really seen a reported issue about that.
But so is it a viable thing to happen?
It is possible, yeah. Some facilities are using a GPS receiver for an accurate timing signal for synchronization of data center, for example. So when you put a drone with a spoofing device on it over that, you can manipulate the timing signal also, yeah. That's possible, but I've not heard about about a real case about that.
Not something that has been reported, but it's possible.
Yeah.
Okay, thank you.
It is possible, but not reported yet. Okay. And yeah, if someone else has questions, I'm walking here outside and then we can see.